Question number 7. At 25 degrees Celsius, the vapor pressure of benzene, given that its weight is 78 grams per mole, that's the molecular weight, is 93.2 torr, that is the vapor pressure. And that of toluene is 28.2 torr. A solution of 1.0 mole of benzene and toluene is prepared. Calculate the mole fraction of benzene in the vapor phase about the solution, assuming that the solution is ideal. Options given are A 0.607, B 0.768, C 0.232, and D 0.393. Okay, so let's start with this. Now, the total pressure, what we know? The total pressure is equal to, we know that it is equal to the partial pressure of the solvent A and mole fraction of A plus partial pressure of B into the mole fraction for B. Correct. So if this is taken into consideration, what do we know about this? First thing, let us say that this is our equation number 1. And the second equation, what we know, which relates with the gaseous phases, are P, that is a pressure, is equal to, that is the pressure into, okay, let's say Y represents the mole fraction in the vapor phase. So vapor phase, now that is equal to partial pressure if we are taking of A into chi of A, right? Now let's take this as an equation number 2. Now therefore P total is equal to, now can we say that P naught of A into chi of A divided by Y of A, because both of them are same or both of them are equal. So therefore we have taken here over here as P total is equal to so and so now. So this is one of the important expression what we have come across. So that is P total is equal to partial pressure of A into chi of A divided by the mole fraction in the vapor phase. So this is one of the important section that we need to continue with. Now, so therefore, substituting the values. Now, if we have taken this for A, let's say this is the third one. So therefore, the same goes with respect to B, that is P total PB into chi of B, the whole thing divided by Y of B, right? So now let's substitute all the values that we have. So for benzene, let's go for A, let's say it is for the benzene, right? So when we are speaking about the benzene over here, so what do we know about it? Pressure that has been given is 93 torr, right? So 93.2 torr. Therefore, and for B, of course, it is toluene. So for the toluene, what we have is P is equal to 28.2 torr, right? Now, these are the two things that we already know. So now let's go with the substitution. P is equal to, for the benzene, all right, so P naught, that is 93.2 into chi A. Now, how much do we have? Chi A becomes as 0.5. Why does it becomes as 0.5? Now, mole fraction is equal to chi of A into chi of B. All right, so mole fraction totally should be equal to 1, is equal to, now 1 mole and 1 mole, right? So 1 mole and 1 mole, so therefore the mole fraction is equal to the number of mole of a particular solute divided by total number of moles. Now let's say this one. So both of them are present in 1 mole. So 1 divided by 1 plus 1. So that is going to be as 0.5. That is 1 divided by 2 is going to be 0.5. As both of them are present in the same amount. So therefore 0.5 for benzene, 0.5 for toluene. All right. So directly taking into consideration as a mole fraction for both of these particular cases as 0.5 moles. The whole thing now divided by YA for benzene. So this is the first expression for benzene, right? So let's take into consideration of now for toluene. So for toluene, pressure is equal to, so how much we have here is 28.2 into 0.5. The whole thing now is going to be divided by YB. All right, so let's have this one. So when we calculate the further concepts over here, what we are going to have, YA, all right, YA is going to be as 93, sorry, that's 93.2 into 0.5. The whole thing is going to be divided by pressure. The same thing goes with the YB over here. So that is 28.5 into 0.5, the whole thing divided by the total pressure. Now, over here, taking into consideration of as YA and YB are going to tell us about the mole fraction in the vapor phases, we can say that YA plus YB should be equal to 1. Correct. Now, substituting these particular values, we are going to have the further sections as. Now, here, let's go for this. So when we have YA and YB is equal to 1, okay, so can we say that for a moment that YA over YB, now let's take this from here, the situation becomes a bit tensed. So YA over YB, YA over YB, so what we have, YA 93 into 0.5. So this particular multiplication term gives me a value of 46.6, the whole thing divided by pressure P. This entire thing divided by 28.5 into 0.5 will give me the value as 14.1, exactly half of 28, right? So divided by P. So YA over YB, now it's quite simple that 46.6 divided by P, the whole thing divided by P into 14.1. All right, now let's take this particular concept things down. So YA over YB, we are going to have it as 46 divided by 14, and that is going to give me the value of 3.30. All right, so now that quite means that YA is equal to 3.30 times of YB. All right, so YA is equal to 3.30 times that of YB, but we already have one expression saying that YA plus YB gives me equal to 1. So if we have that, let's substitute the value. So it is 3.30 of YB plus YB is equal to 1. So therefore, now directly I will calculate the value of YB. I will give you the value of YB, and that is going to be as 0.23. If you solve this particular consideration, you will get this value as 0.23. All right. Now, what is remaining is the value of YA. So YA plus YB should be equal to 1. So YA plus 0.23, because 0.23 is the value of YB, and that is going to be equal to 1. So YA is equal to 1 minus of 0.23, and we have the final answer. YA becomes equal to 0.77. So therefore, if we observe, they have asked only one thing, okay, and that is the value of YB, that is the toluene. Calculate the mole fraction of C6H6. Okay, so if we are going for the C6H6, that is a benzene. Okay, so benzene, what we have is 93 torrs over here, so that is going to be 0.77. So the nearby value what we have over here is going to be as 0.768, which is nearly equal to 0.77. So therefore, the answer is the option B. So that serves the correct way.